Okay, so now after we get the trigonometric form of a complex number, then we can do this problem. Okay, continue to do this problem. So we already found the modulus R, and we also found this argument. Then this negative 7 is equal to R. That is a 7 times cosine of this argument 180 degrees and plus I times sine 180 degrees. Actually, when you simplify this, you see this sine of the 180 degrees is equal to 0, right? And the cosine of the 180 degrees is equal to negative 1. So negative 1 times 7, you still get negative 1. Then just go back to this original number. So this is a simple one. Now let's look at another one. Let's go to the page 622 and let's look at the problem 20. So root of 3 over 6 plus I over 6. Problem 20, we have the root of 3 over 6 plus I over 6. So here we have the A equal to root of 3 over 6 and B equal to 1 over 6. The coefficient of this I is equal to 1 over 6. So now we can get the modulus. Modulus R is equal to the square root of A squared plus B squared. So let's compute this. And simplify. So this is equal to 3 over 6 squared. And this is 1 over 6 squared. So in this way you get square root of the 3 plus 1, you have 4. 4 is equal to 2 squared. So you have 2 squared over 6 squared. And then you get 2 over 3, that is 1/3. So we find the modulus of this vector, of this complex number. Now, let's try to get the argument. So the argument cosine theta is equal to A over R, and A is equal to root of 3 over 6, and R is equal to 1 over 3. Now, you multiply both the numerator and denominator by 6. So this 6 and this cancel, you have the root of 3. And 6 divided by 3, you have the 2. So you have the root of 3 over 2. Then you can first find the arc cosine. Or arc cosine of the root of 3 over 2. And we know this is equal to 30 degrees, right? And you check the complex number again. The complex number is the root of 3 over 6 and plus the 1 over 6 times I. So the point is in the quadrant 1. So theta must be an acute angle, right? So now, actually, this one, theta is just equal to 30 degrees. And then you can rewrite this complex number root of 3 over 6 plus I over 6 in this trigonometric form. So we get the modulus 1 over 3 here and times cosine 30 degrees and plus I times sine 30 degrees. Now let's do one more problem. And this time we need to convert this track form to this a plus bi form. Okay. So write this complex number in the form a plus bi. So 30. So that's page 622, problem 30. We have 6 times cosine 30 degrees plus I times sine 30 degrees. So we first find cosine 30 degrees. This is equal to root of 3 over 2. And sine 30 degrees is equal to 1/2. Then you multiply each term by 6. You have the 3 times root of 3 plus 3 times I. Now you have the 6 over 2, got 3. And then this is in the a plus bi form. So we know if we have a number, a complex number a plus bi, then the conjugate of this complex number is the a minus bi. We just change the sign of the imaginary part. Now, let's see how we multiply and divide two complex numbers in the trigonometric form. So we talk about the products and the quotients in the trigonometric form. Suppose we have two complex numbers in this trigonometric form. Z1 equal to R1 times cosine theta 1 plus I times sine theta 1. Z2 equal to R2 times cosine theta 2 plus I times sine theta 2. Now, let's first look at the product of these two complex numbers. So we have the Z1 times Z2 equal to R1 times R2. Let's put these two modulus together. And then cosine theta 1 plus I times sine theta 1, then times cosine theta 2 plus I times sine theta 2. Now let's expand this product of these two expressions. Cosine theta 1 times cosine theta 2 cosine theta 1 times I times sine theta 2. So you have the I times sine theta 2 times cosine theta 1. And then you have the I times sine theta 1 times cosine theta 2. I times sine theta 1 times cosine theta 2. Then you have the I times I square, which is negative 1, times sine theta 1 and sine theta 2. So you have the negative sine theta 1 times sine theta 2. Now let's see. You have the cosine theta 1 times cosine theta 2 minus sine theta 1 times sine theta 2. Let me put this here.